This is 7.6 day 2, the natural base e. Today we're going to solve equations using logarithms and exponentials along with some word problems. Here are some equations that we're going to solve for rewriting in the two different forms. So the first example, e to the x equals 36. Write an equivalent exponential or logarithmic equation. So you could rewrite this as log base e of 36 equals x. And then if you wanted to solve it, you would push the natural log button in your calculator, which represents log base e, and then 36. And that'll allow you to find out what does x equal. So go ahead and push the natural log and then 36. And then x is approximately 3.58. Example B, write an equivalent exponential or logarithm for this equation. So now it's saying the natural log of 2 is approximately 0.693. Just check with your calculator. Natural log of 2, do you get 0.693? So what this looks like is log base e of 2 is approximately 0.693. If you wanted to convert it to an exponential, that's base e raised to the 0.693 is about 2. So that's how you can convert between the two different forms, exponentials and logarithms. Now we're going to go ahead and do some solving for equations for x. So the natural log of e equals x. What does x equal? So we would go ahead and put in our calculator this piece. So go natural log, and then we put the e in. And you should get 1. If I were to create an exponential out of this, this represents log base e of e equals x. Well, these are inverses of each other, if you remember. They cancel each other out, so you're just up at that little exponent. So x equals 1. Example B, the natural log of 1 equals x. Again, you can use your calculator. Push the natural log and then 1. You should get x equaling 0. Or rewrite it, log base e of 1 equals x. And then write it as an exponential. E to what power equals 1? Well, anything raised to the 0 power is 1. So your answer is 0 here and 1. Let's go on to example C. Example C, the natural log of e to the third. Remember, these are inverses of each other. I have log base e to the third. What happens is they cancel each other out, and you're just left with that power. So x equals 3. Next example, I have a natural log on the left and a natural log on the right. So we have this thing called the 1-to-1 property. So they cancel each other out, and you just have to focus on the x plus 3 and the 14 and solve that like you would traditionally do in Algebra 1. Undo the 3, so minus 3, and you get x equals 11. Substitute it back in to the original equation. Substitute 11 to here. 11 plus 3 is 14. The natural log of 14 equals the natural log of 14. Solve the following for x. Now we have e to the x equals 25. We want to find out what x can be. So one way is to take the natural log of both sides. Then we've learned then that the natural log and the e, they are inverses of each other. So they'll cancel out. So we have x equals the natural log of 25. Now we can use our calculator. The natural log of 25 is approximately 3.21. Next one. 35 to the x equals 20. We want to find out what x is. Well, same as the last problem. We can take the natural log of both sides. You can also take the common log, which is just base 10. This is base e. Then we learn if we have an exponent or a logarithm, we can bring it down in front. So we have x natural log of 35 equals natural log of 20. Then we can undo that natural log of 35. So we divide both sides by natural log of 35. Now with our calculator, enter in the natural log of 20 divided by the natural log of 35. And we get approximately 0.842. Again, substitute these values back into the original equation and check to see, do you get the correct answer? I'm going to stop the slide here.